Welcome to Cosmic Compass, where we journey together through the wonders of the universe. In this video, we'll explore one of the most daring space missions ever attempted, the Rosetta Philae mission. It was a story of ambition, risk, and discovery, a mission that dared to chase a comet across the solar system and land on it for the very first time. Along the way, we'll witness moments of triumph, near disaster, and scientific breakthroughs that changed how we understand comets, and perhaps even how we understand ourselves. So let's set our course for Comet 67P and uncover the incredible story of Rosetta and Philae. Imagine watching in silence as a €1 billion spacecraft drifts into the shadow of Mars, powerless, running only on fragile batteries never meant to last more than a few minutes. Mission control can only wait and hope. Will it wake up again? Or will this be the end? This was the gamble of the Rosetta mission, one of the European Space Agency's most ambitious projects. While NASA often takes the spotlight for daring voyages, Europe has its own shining moment of cosmic exploration. Rosetta and its companion lander Philae achieved something extraordinary. They gave humanity its first close look at a comet, not just from orbit, but from its surface. The target was Comet 67P Churyumov, Gerasimenko, a visitor from the distant reaches of the solar system. For the first time, we could ask questions that had lingered for decades. What are comets made of? Could they have delivered the building blocks of life to Earth? And what secrets about the early solar system lie hidden inside their icy cores? Yet this triumph was not without failure. Philae, the lander, was supposed to conduct experiments for 5 months, but instead survived for less than 3 days before falling silent. What went wrong, and how did this mission still manage to rewrite our understanding of comets and perhaps ourselves? Let's retrace this incredible journey through triumphs, near disasters, and discoveries that continue to shape the way we see our place in the universe. To appreciate Rosetta's achievement, we need to step back to its beginning. Comet 67P is what astronomers call a Jupiter family comet, an object whose orbit is influenced by Jupiter's gravity, keeping it closer to the inner solar system. But its origins lie much farther away in the icy Kuiper belt beyond Neptune. Rosetta was launched on March 2nd, 2004 atop an Ariane 5 rocket. Originally, the mission had been scheduled more than a year earlier in January 2003, targeting a different comet entirely. But a major failure in the Ariane 5 program forced a delay, and when the launch window was missed, a new target had to be chosen. That target became 67P, which happened to be at the right place in its orbit. Once in space, Rosetta embarked on a long and winding journey. To reach such a distant comet, it couldn't simply fly straight out. It needed multiple gravity assist slingshot maneuvers around Earth and Mars to build up the speed to escape the inner solar system. The first Earth flyby came in 2005. Then in 2007, Rosetta swung past Mars at an altitude of only 250 kilometers. For 15 tense minutes, the spacecraft was plunged into the shadow of the planet. Because Rosetta was solar-powered, it had to rely entirely on batteries to stay alive. Had they drained completely, the spacecraft would never have reawakened. The team later called it the €1 billion gamble. But Rosetta survived, even capturing stunning images of Mars as it flew past. That same year, another Earth flyby brought it close enough that ground-based telescopes mistook it for a near-Earth asteroid. It was even briefly listed as a potential impact threat. Along the way, Rosetta also took the chance to visit 2 asteroids. In 2008, it flew by 2,867 Steins, a tiny 5-kilometer wide body in the asteroid belt. Then in 2010, it passed 21 Lutetia, a much larger asteroid about 100 kilometers across. These encounters provided a fascinating comparison between asteroids and comets, rocky relics versus icy visitors. After these encounters, Rosetta went into deep space hibernation for nearly 4 years, conserving energy while it drifted toward its ultimate goal. In 2014, Mission Control reawakened the spacecraft. Its final approach to 67P was about to begin. As Rosetta closed in, the first images of 67P began to arrive. What the scientists saw astonished them. The comet was not a single lump of ice and dust. Instead, it was a contact binary, 2 lobes joined by a narrow neck. The surface was jagged, full of cliffs, valleys, and ridges. Far more dramatic than the smooth, rounded asteroids we had visited before. But this dramatic shape also posed a question. How do you land on something like this? Rosetta wasn't just an orbiter, it carried a lander, Philae, designed to touch down on the surface and directly sample the comet's material. But with the strange shape, rough terrain, and jets of gas escaping as the comet neared the sun, choosing a safe landing site became a monumental task. For months, Rosetta carefully mapped the surface, identifying potential landing zones. Scientists looked for regions that were stable, not too active, and flat enough for Philae to remain upright. Eventually, one was chosen. The date was set, November 12, 2014. Humanity was about to attempt its first ever soft landing on a comet. The world watched as Philae separated from Rosetta and began its slow descent. The lander was equipped with 2 harpoons that would fire into the surface to anchor it. The comet's gravity was so weak that even a small bounce could fling it back into space. For perspective, if you stood on 67P, you could almost jump off into space with your own legs. At first, everything seemed fine. Philae touched down and signaled a successful landing. Cheers erupted at Mission Control, but almost immediately it became clear something had gone terribly wrong. The harpoons hadn't fired. Instead of anchoring, Philae bounced. For 2 hours, the little lander drifted across the comet, making not 1, not 2, but 3 separate touchdowns. At one point, it rose a full kilometre above the surface before coming back down. Finally, it settled upright, but far from its intended site. The problem, its resting place, was a shadowed region where sunlight barely reached. That meant its solar panels could not recharge the batteries. The lander's lifetime, once expected to be 5 months, was cut down to less than 60 hours. Mission Control scrambled to collect as much data as possible. Instruments were activated, samples were analysed, and precious findings were transmitted before the batteries drained. By November 14, Philae had gone silent. And yet there was a twist. In June 2015, as the comet moved closer to the sun, Philae briefly awoke, sending a weak signal back to Rosetta. It even managed one last experiment, a radar probe, that offered clues about the comet's interior. Then, in July, contact was lost forever. For many, it was bittersweet. A mission that seemed to end in failure had, against the odds, still delivered valuable science. So what did this daring adventure actually reveal? The findings were as groundbreaking as the mission itself. Rosetta's close observations showed that 67T was about 5 kilometres across, made of 2 lobes joined at the neck. Fracture lines ran through the neck region, suggesting mechanical stress. As the comet rotated, the 2 lobes appeared to tug away from each other, gradually thinning the connection. Scientists even witnessed boulders 10 metres across being shifted by weak gravity and volatile outgassing. This told us the comet was fragile, porous, and constantly reshaping a dynamic world rather than a frozen relic. Philae's landing revealed something else. The comet's surface was not fluffy, snow-like material, but surprisingly hard, with a thin, dusty crust above solid water ice. The drill struggled to penetrate, showing that comets were more resilient than imagined. In its brief working time, Philae detected 16 organic compounds on the surface, including 4 never before observed on a comet. These weren't life themselves, but they are the ingredients from which life can emerge. Meanwhile, Rosetta collected thousands of dust grains from the comet's halo, These grains contained complex carbon-based molecules along with elements like magnesium, calcium, silicon and iron. Most importantly, they retained hydrogen and oxygen, evidence that these particles were ancient, preserved from the very birth of the solar system. Perhaps the most anticipated discovery was about water. One leading theory had been that Earth's oceans were delivered by comets billions of years ago. But Rosetta's instruments measured the ratio of deuterium to hydrogen in 67P's water vapour. The result was strikingly different from Earth's oceans. This suggested that comets like 67T were not the main source of Earth's water. Instead, asteroids, though drier today, may have once held more water and been the true contributors. Rosetta also picked up mysterious oscillations in the comet's atmosphere, which scientists at first thought might be a magnetic field. They even converted Hinterkit into sound a strange alien hum. But Philae's instruments showed the comet had no magnetic field at all. Instead, the sound was produced by the solar wind interacting with the comet's gas, creating what's known as a diamagnetic cavity. In every discovery, Rosetta and Philae challenged our expectations. Comets were not simply dirty snowballs, but complex, dynamic, and chemically rich worlds. By 2016, the comet was moving farther from the Sun, and Rosetta's solar power was weakening. Instead of letting the spacecraft drift powerless into space, mission planners chose a dramatic end. On September 30th, 2016, Rosetta was commanded to descend slowly into the surface of 67P. As it fell, it continued to transmit images, each sharper than the last, until the signal ceased. It was a symbolic ending. Rosetta and Philae, now resting on the comet forever, had given humanity an intimate glimpse into a type of object that has existed since the dawn of the solar system. Their story ended on the comet itself. Between them, Rosetta and Philae revealed a world more complex than anyone had imagined. They showed us how fragile, dynamic, and ancient comets truly are. They tested the theory of water delivery to Earth, and they expanded our knowledge of organic chemistry in space. Most of all, they reminded us that space exploration is not just about success, it's about risk, resilience, and discovery even in the face of failure. As we look up at the night sky, we now know a little more about where we came from and perhaps where we are going. Rosetta and Philae may be silent now, but their legacy continues to echo quietly, like the strange hum of a comet drifting through space. Space exploration is only just beginning, and each mission takes us one step closer to understanding our cosmic origins. Let's look forward to the next daring journey. The Rosetta Philae mission reminds us that space exploration is never easy. It's filled with risk, with setbacks, and with unexpected turns. But it's also filled with wonder, with discovery, and with the thrill of going where no one has gone before. Today, Rosetta and Philae lie silent on Comet 67P, frozen in time, but their story continues to inspire, reminding us that even when missions don't go exactly as planned, they can still unlock mysteries that reshape our understanding of the cosmos. If you enjoyed this journey, don't forget to like, share, and subscribe to Cosmic Compass. Together, let's keep exploring the universe, one story at a time. Until next time, keep looking up, because the cosmos is waiting.